In question number 11, the diagram shows part of the curve y equals to x minus 1 to the power minus 2 plus 2, and the lines x equals to 1 and x equals to 3. The point A has coordinates 2, 3. The normal to the curve at A crosses the line x equals to 1 at B. In part 1, we have to show that the normal AB has equation y equals to half x plus 2. Now, to find the equation of the normal, we'll first have to find the gradient of the normal. For that, first, we'll find the dy dx of the curve. So the dy dx of the curve will be equals to, so we'll multiply minus 2 by the coefficient. So that will become minus 2 into x minus 1 to the power minus 3. Multiplying it with the derivative of x minus 1, this will be 1. And the derivative of 2 will become a 0. So the dy dx can be written as minus 2 upon x minus 1 whole cube. At point A, the x value is 2. So when x is equals to 2, dy dx will be is equals to, so that will become minus 2 upon 2 minus 1 whole cube. So 2 minus 1 is 1, and minus 2 divided by 1 will be minus 2. Now this dy dx represents the gradient of the tangent, so that is minus 2. If the gradient of the tangent is minus 2, it means that the gradient of the normal will be a negative reciprocal, which will be positive 1 upon 2. Now to find the equation of the normal, we'll use the formula for the equation of a line, which is y minus y1 is equals to m into x minus x1. So y1 is 3 as given in the question. So this will become y minus 3 is equals to 1 upon 2 into x minus the x1 value will be taken as 2. Now expanding this, we'll get y minus 3 will be is equals to, so we can write this as half x minus 2 upon 2, which will become 1, and minus 3 will go over on the right hand side and become a plus 3. So the final equation can be written as given in the question, y will be equals to 1 upon 2x, and minus 1 plus 3 is a plus 2. Now in part 2, it says find showing all necessary working the volume of revolution obtained when the shaded region is rotated through 360 degrees about the x-axis. Now, the formula to find the volume is given by the formula pi multiplied by the integral of y squared dx and the limits b and a. So we can now divide this curve to find the volume of the shaded region. We can divide it into two parts. We know that this coordinate will be 2. So we can first find the volume under the line and then the volume under the curve, and then add the two volumes to get the volume under the shaded region. Now we already have the equation of the line, which is half x plus 2. So to find the volume under the line, the volume will be is equals to, so we'll write volume will be equals to half x plus 2, and that will become a whole squared dx, and the limits will be the upper limit, which will be 2, and the lower limit will be 1. And we'll add pi to the final answer once we have applied the limits. Now in the first step, we have whole squared it. Now we'll have to integrate it. So when we integrate this, this will become half x plus 2. The power will increase by 1, and we'll divide it by the new power, which is 3. And also we'll divide it by the derivative of half x plus 2, which is half. So 3 will multiply by half, and that will become 3 upon 2. So we are dividing this by, so this we can write it as 3 upon 2. Now when we bring in the multiplication sign, so that will become 2 upon 3. So the integral will become 2 upon 3 into 1 upon 2x plus 2 to the power 3. Now once we have integrated this, we can apply the limits. So the limits are 2 and 1. So applying first x equals to 2. Into this equation, we'll get 2 upon 3 multiplied by, so that will become 1 upon 2 into the x value is 2 plus 2 to the power 3. And then applying the lower limit, which is x equals to 1. So that will become 2 upon 3 into half into 1 plus 2 to the power 3. So 2 and 2 will cancel out over here. This will become 1 plus 3, which is, so 1 plus 2, which is 3. 3 cube is 27, and 27 times 2 will become 54. So this will become 54 upon 3, and this will subtract from the lower limit. So this will become half plus 2. So half plus 2 is 2 whole 1 upon 2, or 5 upon 2. And we can write it as 2 upon 3 into 5 upon 2 whole cube. Simplifying this, we'll get, so 5 cube is 125. 125 times 2 will become 250. So this will become 54 upon 3 minus 250. 2 cube is 8, and 8 times 3 will become a 24. So 54 upon 3 is 18, and 18 minus 250 upon 24. So taking the LCM, we'll get, so this will be 1 over here, and this will multiply by 24, and this will multiply by 24 as well. So simplifying this using the calculator, so we'll get 18 multiplied by 24. So if we substitute this in the calculator, this will become 18 times 24, which is 432 minus 250. That is, okay, so that will become 18 times 24 minus 250. So that is 432. 432 minus 250, that is equals to 182 upon 24. And if we substitute 180 upon 24 in the calculator, that will become 91 over 12. So we can add pi to this answer now. This is 91 upon 12 pi, which is the volume under the line. Now, once we have the volume under the line, to find the volume under the curve, we'll again use the same formula, and we'll use the equation of the curve. So the equation of the curve was y equals to x minus 1 power minus 2 plus 2. So this was x minus 1 to the power minus 2 plus 2. So we'll have to first whole square this and apply the limits. So the limits in this case will be 3 and 2. As we can see over here that the upper limit is 3 and the lower limit is 2. So now first expanding, because there's a whole square, so we can apply the formula a squared minus 2ab plus b squared, or a squared plus 2ab plus b squared. So a is x minus 1 to the power minus 2. That will become, so expanding this, that will become x minus 1 to the power minus 4 plus 2 into 2. So that will become 4. So this will be 4 into x minus 1 to the power minus 2 and plus 2 squared, that will be equals to 4. Once we have expanded this, now we'll have to integrate this. There is still integration sign over here with the limits 3 and 2. Now integrating x minus 1 to the power minus 4, that will become, so we'll increase the power by 1, that will become minus 3. We'll divide by the new power, which is minus 3. Then integrating x minus 1 to the power minus 2. So we'll increase the power by 1 and divide by the new power, that is minus 1. And integrating 4x, that will become 4x. Once we have integrated, we can simplify to write it as minus 1 upon 3 into x minus 1 whole cube minus 4 upon x minus 1 plus 4x. And now we can apply the limits. So the upper limit was x equals to 3. So this will become minus 1 upon 3 into 3 minus 1 whole cube minus 4 upon 3 minus 1 plus 4 times 3. So that will be equals to 12. So now simplifying this, before we substitute the lower limit, we'll get minus 1 upon, so this will be 3 times 2 cube 8 minus 4 upon 2. So that will be 2 plus 12. Minus 2 plus 12 is plus 10. So we can write this as 10 minus 1 upon 24. And simplifying this by taking the LCM, that will become 240 minus 1, which is 239 upon 24. And now applying the lower limit. So the lower limit was x equals to 2. So applying x equals to 2 into the equation, we'll get minus 1 upon 3 into 2 minus 1 whole cube minus 4 upon 2 minus 1 and plus 4 times 2, which is 8. So 2 minus 1 is 1. 1 cube is 1. So 1 times 3. So this will become minus 1 upon 3 and minus 4 upon 1. So that will become minus 1 upon 3 minus 4 plus 8. 8 minus 4 is 4. So this will be 4 minus 1 upon 3. This will become 3 times 4, 12. 12 minus 1 is 11 upon 3. So once we have these two values for the upper and the lower limit, to find the volume of the shaded region, we'll subtract these two values. So that will become 239 upon 24 minus 11 upon 3. So if we substitute this in the calculator, that will become, so this is 239 upon 24 minus, and that is 11 over 3. So that is equals to 151 over 24. And once we have this answer, we can find the volume of the shaded region by adding the volume under the line. So the shaded region will have a volume of 151, and they will have to add a pi over here. So 151 upon 24 pi plus the volume under the line, which was 91 over 12 pi. Substituting this in the calculator, so we have 151 over 24, and we'll add it to 91 over 12. So the final answer will become 111 over 8 pi. So that is 111 divided by 8 pi as the volume of the shaded region.